So let's start marking the voltages in this entire circuit. Right over here, we can approximate the node voltage as equal to 1 volt because this is a voltage divider, and at this point we can approximate this as 100 divided by 100 plus 400 into 5 volts. So this is approximately 1 volt because we are disregarding these load resistances. In this divider circuit, again disregarding the load resistances, we can say that the voltage across the RTD will be RTD divided by 1 plus RTD multiplied by 1 volt, where RTD is in kilo ohms, and Vx, which is the voltage difference across this 1 kilo ohm resistor, we can state this as 1 volt minus of VRTD, or we can frame a voltage divider equation out of this also and state this as Vx being 1 divided by 1 plus RTD. Again, RTD is in kilo ohms. Coming over to the difference amplifier, we find that this is the input voltage across the difference amplifier. So the output of this amplifier will be equal to V sub x because all these resistances are same. Come over to the zero adjustment pot, and as we said before, you can think of this particular point as having a node voltage of V volts. These resistances are same. This is an inverting adder circuit, so V1 will be equal to minus of V minus of voltage at this node, which is the same as VRTD. Moving forward, you have the span adjustment pot, but this is an inverting amplifier, so we can break this 100 kilo ohm into two parts, and the wiper position right here till this node will lead to a resistance of Y kilo ohm, and the other half is 100 minus Y kilo ohm. So if you remember from the experiment, we had a switch and we flipped this switch to the ohm point, and the display showed the corresponding value of resistance of the RTD in ohms. So how do we go about finding that display value? You have Vref, which is the same as Vx. So this is Vref, which is the same as Vx. You have Vin, which is the same as the RTD voltage. So this is Vin, plus terminal is connected to this point, minus terminal is grounded. So the voltage between these two nodes is the same as the voltage across the RTD, which is VRTD. So ohm display, based on this ICL 7107, we have seen this equation as 1000 multiplied by Vin by Vref. And this is ratiometric. This is a ratio of the input voltage to reference voltage. So input voltage is VRTD and reference voltage is Vx. Substitute the values based on these equations, and then we come to this third equation. 1 plus RTD cancels out, and you get the ohm display as 1000 multiplied by RTD. So the ohmic display is directly proportional to the RTD resistance. If you consider one example, this is a PT100 RTD. So at 0 degree centigrade, you should have 100 ohms, which is equivalent to 0.1 kilo ohms. So the ohm display over here should be 1000 multiplied by RTD, which is 0.1 kilo ohm, and you get 100 ohms. As another example, let's say the RTD reading was 0.1 to 1K. So at a particular temperature, this was the value of the RTD resistance. Now the display will be 1000 multiplied by 0.121, which is equal to 121.